32,000 tons of steel. 7 decks, each the length of a football pitch. 4 engines, burning 2,500 litres of fuel an hour.
So when you're out at sea, I can't imagine the noise that makes.
One massive feat of engineering. The North Sea ferry, the Pride of Bruges.
Wow. Can't get too much more up close and personal with a ship than we are here.
Battered by the sea for 25 years, it's being taken out of the water for the biggest overhaul of its life. As key parts are stripped down, there's a unique chance to explore deep within its hidden features.
We're as far as any sensible person would go.
Every complex system must be rigorously tested and repaired before it can return to service.
If you've got a high clearance, you could actually lose your rudder.
So these checks,
they're very important. They're very important.
A 120-strong team of highly skilled engineers take on the challenge.
To replace all that is a massive job.
They must examine over 1,000 separate parts and repair over 10,000 square meters of steel hull.
This wasn't being done.
The steel itself will just deteriorate.
And we'll reveal what happens to these giants when they reach the end of their working lives.
They're just getting munched up by this shearer.
And how in their death, they're given a new lease of life.
Wow. It's just an incredible firework display.
This is Engineering Giants.
I'm Rob Bell. I'm a mechanical engineer, and I've always loved to get my hands on complex machines to discover how they work.
I'm Tom Wigglesworth. I'm a trained electrical engineer with a passion for big machines.
And this is the Pride of Bruges, the North Sea ferry that's going to help us explore exactly how a ship works.
It's arriving in Newcastle, where it will spend the next 3 weeks being stripped down.
Pride of Bruges, your town pilot, we're coming to you now.
God, we're like a mouse coming alongside an elephant here. Look at this.
All the ship's key components, including its engines, propellers, rudders and hull, will require detailed checks and repairs. The problem is that many of the most important parts of the ferry are underwater.
Before any of the checks can take place, the first challenge is actually to get this beast into the dock. And that's no mean feat.
Engineers won't know the extent of the work ahead of them until all 32,000 tons, the weight of over 2,000 double-decker buses, are safely out of the sea. And to do that, the ship must now be precisely manoeuvred into the dry dock facility at the A&P shipyard on the Tyne.
The job of all the guys here around the dock is to get this ship absolutely central and in exactly the right position in the dock. On the bottom of the dock, underneath the water, are what's called docking blocks, and they've been laid out in exactly the right position for the design of this ship, the Pride of Bruges.
Earlier today, I met up with site manager John Leckie to find out how his team was going to accomplish this engineering feat.
These blocks that the ship will sit on, they've been put in particular positions for this ship, in accordance with its docking plan.
The metre-high steel bases are topped with oak blocks, which cushion the immense weight of the ferry, preventing damage to its hull while enabling engineers to work right underneath the ship. Once they're in place, the team can flood the dock.
If by some means it started right now, will we have time to get out?
How quick a runner are you?
Well, pretty quick, but...
Using water from the river next door, fed by gravity, the dock is flooded with 133 million litres of water, equivalent to 53 Olympic-sized swimming pools.
Oh, wow. Look at it come out. It's absolutely flooding out. That did not take long at all.
It takes another 3 hours before the water in the dock is at the same level as the river outside. Then, the gate can be dropped. Engineers have calculated where the hull needs to be positioned in relation to the dock so that the ship ends up exactly above the blocks. Tonight, this task is particularly challenging as there's a strong crosswind.
This is quite a tense moment, and it was the bit that they weren't sure whether they were going to actually carry out tonight because it was so windy.
Come back down to 1 on the starboard side.
With the margin of error less than a metre, the ferry is attached by steel lines to winches known as mules, so that the ship can be precisely manoeuvred from a central control tower.
Okay, Alan.
Hello, we're just starting to drift back a little bit there now.
It's such high precision work. And with the wind coming across as well, it's certainly not easy.
Caught by a gust of wind, the ferry is pushed perilously close to the edge of the dock.
Okay, look at this war, Sean, this war.
Any damage sustained to the ship on its way into dock could cost millions and set the whole schedule back days.
Sean, let's see with the Propeller, please. David Sagan.
Okay, Mick, so let's go. Hello, we're drifting back there now to the starboard side. We're about 2 metres to the port side.
Finally, after 2 hours of manoeuvring, the team get the ferry into position and raise the gate.
Next comes the most dangerous part of the operation. If the ship is not in exactly the correct position above the blocks as the water is pumped out, the hull could be badly damaged. These 3 electric pumps will drain the 133 million litres of water out of the dock.
Each one pumps out 18,500 tons of water an hour.
After another 4 hours, it becomes clear that the engineering team's measurements are spot on as the Pride of Bruges finally comes to rest on its blocks.
Wow. Can't get too much more up close and personal with the ship than we are here. And you can see the effect that the weight of this ship, all 32,000 tons of steel, has had on these docking blocks. It's very intimidating.
With the Pride of Bruges now out of the water, for the first time in years, engineers, including site manager John Leckie, can examine and begin to repair the most important part of the ship, its hull.
So, John, now with this close to the vessel, it strikes me that there's actually very little of it under the water.
Volume displaced by what's under the water equals the weight of the vessel in its entirety. So there's actually quite a lot under the water, especially with this type of ship.
So if you lowered it into the water, as it started to enter the water, it would displace 1 ton, 2 ton, 3 ton, 4 ton. When that displacement weight matches the weight of the ship,
yes,
it stops.
Yeah.
It floats.
Sits and floats, yeah.
The shape of a ship's hull depends on the type of work it's designed to carry out. For speed, V-shaped hulls are best, enabling ships to cut through the water, minimising drag. For stability, a boxy U-shaped design like our ferry is better, creating more cargo space and minimising rocking. But the shape of a ship's hull isn't enough on its own to ensure its stability and seaworthiness. A perfect level of buoyancy is also needed, and to make that happen, the ferry can pump up to 2,200 tons of seawater into the network of ballast tanks that run throughout the lower part of its hull. The ship is designed to sit at a certain depth in the water. If the ship was empty, carrying no load, it would actually sit so high up in the water that it would appear unstable. Now, this is a bit of an extreme example. That's not classic ship shape. We can make even this sit in the water with a good degree of stability if we put enough ballast in it and cause it to lower its buoyancy point, like that. While the dock was being drained, the ballast tanks on the Pride of Bruges were emptied, so that engineers could begin the filthy job of cleaning out the water inlets, known as sea boxes.
Hey up, there's a man in there. Is he a contractor or is he just dodging a fare?
Engineer Colin Grant has the job of ensuring that this major overhaul runs smoothly.
Guys are working up there, cleaning the mud and everything that accumulates, because eventually it will clog up and the ship's got a problem.
So when the ship needs a drink, this is its mouth?
It is, as it has to pull in cooling water all the time.
Yeah, for the engine.
And put it out again, exactly.
Yeah.
The forward end of the engine room has rows and rows of big pumps for different purposes. Some to circulate water around the engines, and there's lots of engines in there, and some to push the ballast water up when it's required, right through the length of the ship.
Once the sea boxes have been cleaned, engineers will have to squeeze through tight access holes as they venture deeper into the ship's ballast tank system to inspect and repair their steel interior against corrosion.
The thing that makes this one stand out for me is that we have a great big ship here, and you've got the daftest access to it you've ever come across in your life.
Colin qualified as an engineer at the Ministry of Defence and has always been passionate about ships.
There are all sorts of plans of the ships, but the one that we need for this exercise is this.
Before Colin's team can begin examining the ship's labyrinth of ballast tanks, he first needs to check that they're safe and that no water remains inside them.
So normally, when the ship's out at sea, this would all be filled with water?
It would, yes.
Part of the ballast tank system?
Yep.
It's pretty pokey around here.
Yep.
The tanks are divided into a series of smaller pockets designed to prevent the volume of water, equivalent to an Olympic-sized swimming pool, from sloshing around the hull and making the ship unstable.
So Colin, now we're pretty much right down inside the forepeak now.
We're as far as any sensible person would go.
Moving around inside these tanks is cramped and claustrophobic.
As part of the check, you'd have engineers coming down here to do what kind of maintenance?
The condition of the shell has to be checked. It's steel, it rusts, and therefore it has to be monitored, looked at. All ships of this kind, in effect, are two things. You've got the lower part that sits in the water, and that's the real ship. It's got all the machinery in and everything, yes. All the stuff up a height, the passengers go in and the cars go in and all that stuff, is cargo on the actual ship, even though it's a permanent part of it.
Yeah.
This is the bit that has to do the work of getting from here to there safely.
And that safety depends on making sure that the hull sits at the correct level in the water. Too heavy a load and the ship could become dangerously low in the water and susceptible to swamping. So the simple horizontal line across the circle, the plimsoll line, indicates the maximum load level.
The other little marks there are indicators for different particular conditions, which would be fresh water and salt water, or, you know.
And is that because fresh water and salt water offer different buoyancies?
Different densities. The salt water is more buoyant, it's denser than fresh water. And similarly, cold water is more buoyant than warm water.
Cold water is more buoyant than warm water? Yeah. I never knew that.
Correct, yes.
And the Bruges is designed to compensate for these variables by pumping water in or out of its ballast tanks.
Oh, freedom.
A part of this ship that I'm keen to get out of.
I don't envy the guys who have to actually do their work down there. Whew. Oh, that's hard work. How's that, Colin? One of the perks of the jobs?
Wouldn't do without it. Love it. I wouldn't want everybody to know this, but that is one of the attractions of the job. I get to go places where normally nobody goes.
It's brilliant. It's a real privilege to come along with you.
I went to become an engineer because anything internal combustion, anything that goes banging up and down and round, and that's, and the bigger the better.
It's in the areas of the ship beneath the waterline that most of the important maintenance work over the next 3 weeks will take place. This is where many of the ship's most vital components are located, and where I found P&O's chief engineer Hans Pronk. He was part of the team that took delivery of the Pride of Bruges 25 years ago.
My roots are at sea, so seawater is in the veins.
Yeah.
Hans's engineering team are about to run tests on a part of the ship that few passengers would even know exists.
Hans, why is this little room so important to the passengers?
Comfort. Comfort for the passengers.
This controls comfort.
The ferry is fitted with retractable fins, known as stabilizers, which help limit the rocking motion at sea that can cause seasickness.
So this is the actuator that pushes the stabilizer arms out?
Yes. So, and at the moment in dry dock, we get them out for repairs, cleaning, maintenance and whatever.
During the tests, engineers will be checking that all the hydraulic systems are functioning correctly and that both stabilizers are perfectly synchronized to work together.
These would only normally be deployed in stormy weathers. The flaps at the back are controlled and move up and down. And they counteract the rolling of the ship from side to side. As this flap goes up, on the other side the flap will go down. Now the really clever thing about these is that they're controlled automatically by the ship through use of a gyroscope system, such that when that gyro moves to one side because of the rock of the ship and the roll of the waves, this thing knows exactly what to do, and it knows how far to turn because of how big those waves are. Clever stuff.
The Pride of Bruges was built in Japan 25 years ago, specifically to carry passengers and cargo 200 miles across the North Sea.
It's high up from there.
Inside, 3 freight decks can carry up to 850 vehicles.
Above the freight decks are 4 more levels to accommodate over 1,000 passengers and crew, complete with 2 restaurants, a nightclub, a casino, and a hotel with 350 cabins.
It's amazing.
It's just this massive, almost like a town with all these.
Well, you wouldn't know you at sea if it wasn't rocking about all over the show, would you?
Coordinating the maintenance of a machine this large is a massive task. The Newcastle engineering team are due to return the Pride of Bruges to the North Sea in just 20 days' time. Delays would be disruptive and costly. Working to a tight deadline, the team's biggest challenge is to repair thousands of square metres of steel, which is showing its age.
Just try and keep a nice even pattern.
While at sea, the whole steel surface has come under constant attack from marine life.
I mean, if this wasn't being done,
the steel itself will just deteriorate.
Seawater is also corrosive and would have caused much greater harm were it not for these metal bars, currently being replaced by Richie Aitchison.
Richie, what is this piece?
It's anode, sacrificial anode.
Sacrificial anode?
It protects the steel, basically.
Yeah.
Protects the steel.
This is a new one, is it?
This is a new one.
So these are put on the site. How many of them are on the ship?
On the ship, about 50 in total.
The sacrificial anodes are made of zinc, a more reactive metal than steel, which means corrosion attacks them first. As their name suggests, they sacrifice themselves to save the hull. While engineers carry out repairs on the steel exterior of the ship, inside, work is underway to replace 2 steel floors, each the size of a football pitch, in the ferry's car decks.
It's incredibly noisy down here, Neil.
Yes.
Overseeing this complex engineering project is Neil Farquhar.
The reason we're replacing the steel is the wear and tear over the years with the tracks and stuff that goes
The steel
back
actually
and forth.
wears down.
Oh yeah, it wears
it?
down. You've got to remember this 18, 20 tons travelling back and forth on trailers and stuff. If it goes below a certain millimetres, it has to be replaced. To replace all that is a massive job.
To strip out the old decking would take months, so engineers will be fixing a new level of steel above the old one, saving time and money.
The blue machine on the left-hand side is what we call a blast track machine, which shoots shot blast onto the surface to make it absolutely spotless.
Oh, it really does, doesn't it?
So that leaves the welders, the clean surface to come along and...
Like filing it down before you...
Exactly.
Over the next 3 weeks, the team not only have to grind the old decking down, but they also have to remove hundreds of manhole covers and fixtures and refit them to the new surface.
How thick a piece are you adding on top?
6 mil.
6 mil more? That should see it right for another 10 years.
Yeah, at least.
Yeah. Extending the life of the ferry is the major goal for this overhaul, and a week into the process, there's still much to do. Over 600 square metres of flooring needs to be relaid as part of the passenger deck's refurbishment. The critical moving components that take the brunt of the forces at sea need to be checked and renovated. And all 4 lifeboats must be removed.
Okay.
These potentially life-saving vessels can carry up to 150 passengers each. They'll be thoroughly examined along with the release mechanism that lowers them into the water.
Part of our service is to make sure that they are working and functioning correctly.
Yeah.
Put them into the water, check the release system, and do the maintenance.
Safety on the ship is paramount and the main focus for the Newcastle engineering team. They're being helped by key members of the ferry's Dutch crew, who have stayed on board to operate the controls and working parts of the vessel.
An old ship, 25 years plus, well maintained, well looked after, good crew on board who love the ship. They do 2 weeks on, 2 weeks off, and obviously treat it as a home.
It's a good team. We've got about 120-ish crew working together with all the people. That's the most important thing. That will help you through the 2 weeks.
The interaction is really great on this ship. Different nationalities, and yeah, that's why I love it.
Sailing for 2 weeks on the ship and we're 2 weeks at home. Enough time to spend at home with your family.
No one knows the Pride of Bruges better than its crew. Today, they're working with Colin and the Newcastle team to operate the ship's 2 4-ton anchors.
They need to examine their 329-metre chains, stored in lockers deep in the bow of the vessel for potentially lethal wear.
The anchors are the only brakes that the ship has. Right. It either hits something solid, which is undesirable,
unadvisable, yeah,
and the captain gets embarrassed, or you hang on to what's down there. The ship will not stand still.
What are we looking for in that inspection?
Any defects. That rubs on that.
Yeah.
Naturally, that causes wear. Remember, if they are actually anchored, those things are working all the time.
Yeah.
And there's a maximum wear allowed on them.
To accurately measure the wear on every single link, all 329 metres of chain is released, an operation rarely carried out on this ferry, except in emergencies.
You can see the rust flying off of it as the pressure of each one of the links of those chains goes through the teeth on the wheel. It's just grinding it straight off.
Next, the team must carefully organise the chain along the bottom of the dock, a potentially dangerous task that has crushed dock workers in the past.
They load the chain onto the ship in lengths. After they've loaded one length on, you can see they join it with a red link. After one length, they paint one link either side with white paint. After two lengths, there's two links either side get painted white. After three lengths, three links. So you can see at a glance exactly how much chain you've fed out.
The anchor prevents a ship from drifting away due to the currents or tide.
A common misconception is that it's the anchor itself that acts as the main weight to secure the ship in its position. In fact, it's the weight of the chain that holds the ship in place. The anchor is merely there to keep the chain in the correct place on the seabed.
The final link in the chain is attached to a single pin deep in the bowels of the vessel.
You pull the pin there, which is painted down. There's a backup on everything.
Yeah, of course.
Pull that pin, so that's there so it can't work its way out while nobody's looking.
Yeah.
And then you get your mightiest crewman with him, hit him, knock it out. That pin goes through the bitter end, the last link of the cable.
So the last link of the chain is called the bitter end.
Yes.
And the whole anchor and the whole chain is connected to the ship by The bitter end.
Exactly. Or more importantly, the ship is connected to the anchor by the bitter end.
Releasing the bitter end would be the captain's last resort, casting the ship adrift in the sea.
You build a ship and you hope that will never be used, except for normal anchor chain changes.
Yes.
The anchor and its chain is 25 years old, the same age as the ship. And like many of the ship's 10 million components, as it gets older, it will require an increasing amount of maintenance and repairs. In the end, the Pride of Bruges will simply become too costly to keep running. Then, it will end up at a shipbreaking yard like this one in Belgium, the largest of its kind in Europe. Here, over 50 ships a year are plundered for spare parts and broken up. It's the perfect place to look even more closely at how all ships are built.
There's all manner of activity going on here. Ships being sailed in to get cut up, scrapped, and it all gets loaded up and taken off to be recycled.
Ships usually arrive at the yard in full working order.
Looks like it's just been completely abandoned.
The salvage team, led by Mario Mias, then get to work removing any valuable components left on board.
That's a pretty massive engine.
A working engine could fetch over £50,000.
So how much of this weigh, roughly?
27 tons.
27 tons.
Yeah.
27 tons of engine.
Yeah.
The team must be careful. Removing a heavy engine while the ship is still afloat can weaken its thin, finely balanced hull, snapping it in half.
I mean, that would be disastrous. You got people on board cutting and suddenly...
People on board, residues of oil into the water, so...
Let alone the value of the ship as well that you could destroy.
It would be a catastrophe. Kan uitlopen, hè?
That's it, it's down. Job done.
Engine safely out, the remaining hull is now light enough to be hauled up onto dry land, to be cut up and recycled.
Effectively, we're just dragging it from the sea up here onto dry land.
This Mexican dredging vessel used to pump sand and silt off the bottom of South American ports. It has a hull that follows the same principle and dimensions of our ferry, just half the size.
Stood in front of this perfect cross-section of a ship, cut right through it. Just gives you a brilliant picture of the structure and what goes on inside. I mean, better than any engineering drawing could ever give you. And whilst this is obviously built and designed to transport cargo, and our ship, people and cars, the principle's very much the same. The flat bottom hull and the ballast tanks on the side. The other great thing about this cross-section is it allows you to see how thick the hull is, or in fact, actually, how thin it is. That's probably, what, a couple of centimetres at max? Can you just imagine how something as thin as this could get ripped to shreds if it came up against something solid like a rock?
It will take another 2 weeks for the salvage team to cut up the rest of this 2,000-ton hull, ready to be recycled. Our ship, the Pride of Bruges, should be at least another 10 years away from this stage of its life cycle.
In Newcastle, the ferry's now halfway through its 3-week overhaul, and so far, the engineering team are on schedule. Throughout the process, one of its 4 diesel engines has been ticking over to provide electrical power to the ship's control systems.
Right at the back, or the aft of the ship, the real business end. And down here is where the engines are. The power, this beast of a vessel.
It's the heart of the beast. That's where all the action is. It's alive, and it pumps the energy through the ship, and you can feel it when you're in there. You can't hear anything else, but you feel it.
Even with ear protectors on, When the ship is at sea, it's simply too loud in the engine room for engineers to work safely for long periods. So while the ship is in dry dock, Chief Engineer Hans Pronk and his team have just a few days to check the thousands of valves for any leaks and carry out important systems checks on the engine's complex electronic controls.
So you're able to see here and actually control everything out in the engines, all the pumps, all the generators.
All the things will be displayed on a screen like this. As you see, the controls over here are for pumps, the controls for propellers, the controls for generators, the control for main engines, clutching, declutching,
steering,
everything.
Despite the noise and heat, Hans is never more at home than when he's in an engine room.
When you're out at sea, it's even more noisy than it is now down here.
Yeah. You definitely need a lot of air protection.
At sea, all 4 engines would be running, constantly driving the ship's 2 propellers, as well as supplying the ship with hot water and enough electricity to power a small town.
I mean, this really gives you an idea of the size of the engines and the pistons. So the diameter of a piston inside the engine is that.
A piston in a regular car engine is closer to the size of a fizzy drink can.
This piston here, that's just been refurbished, has it? Ready to be used again?
Yes, you see, it is not brand new.
Yeah, you can see.
But it's fit for use.
How much would one of these cost new, roughly?
About 7,000 for the top part, because it is being split.
Yeah?
And then you have the lower part, there's another 7,000 roughly.
So around 15,000 pounds.
In addition to 30 pistons, costing £182,000, there are tens of thousands of valves, pumps and pipes, all working together to supply the ship with the power it needs.
So what's the power that we've got on here then, Hans?
It's 5,760 kilowatts.
The power output from average cars, what, in kilowatts?
100 kilowatts about.
So that means this is about the same power output as about 58 cars.
Yes.
In total, the ferry's 4 engines generate a power equivalent to over 200 cars. And on a 14-hour crossing of the North Sea, that means the Pride of Bruges will get through over 30 tons of diesel fuel. Back at the shipbreaking yard in Belgium, a fuel tank has been split wide open, revealing what the vessel consumed and how it consumed it.
The fuel they use on ships is one of the cheapest, real heavy fuel oil you can get. I mean, look at it. I mean, this is kind of crude oil once you've taken off gas, petrol, diesel at a refinery. This is kind of what's left. It's like treacle. So on a ship, it has to go through, the fuel goes through 3 different stages before it can actually be injected into the engine and be burnt. The pipework you can see running through, it's kind of like the heating element at the bottom of a kettle. This is used to heat up the fuel. So it goes from this really viscous, thick, sticky stuff into something more liquid that they can start pumping through the fuel system.
So it gets thinned out by being kept warm?
Yeah, it gets thinned out. But it's not ready to be burnt yet. Because actually in this, you've got all sorts of impurities, there's water in there as well. And they've got a really clever system for separating out the stuff that we don't want, so we get a fuel oil that is burnable.
And that system is called a centrifuge, which I'm going to demonstrate with a bicycle and a bottle, full of a mixture of sand, water and oil to represent the ship's fuel and its impurities.
So I'm going to get this wheel spinning here. Much as it would be on the centrifuge on a ship. Now as that spins, the acceleration forces the heavier objects, or the denser objects, towards the outer edge of our bottle. So let's have a look at what we've been left with.
Wow!
With our little makeshift centrifuge. So you can quite clearly see there, the heavier, denser stuff was thrown right out. And that's the sand, that's the impurities within the fuel on the ship. Then you've got the water, that represents the water in the fuel on the ship. And up top, you've got the least dense liquid in there, and that's the oil. And that would be the fuel oil on the ship, which can then be tapped off and burnt in the engines.
Very good. At sea, 2,500 litres of this fuel is burnt every hour on the Pride of Bruges, generating over 40,000 horsepower. most of which is used to turn the ship's two colossal propellers, linked to the engines via these 130-metre-long shafts.
This shaft runs right from the transmission right out to the propeller. Yes, absolutely, yeah.
The shafts are so long because if the engines and propellers were next to each other, their combined weight of over 200 tons would place too much weight in the stern of the ship, making the ferry unstable.
The propellers work by pushing water in one direction, causing the ship to be moved in the other. The angle and speed of the blades affect the volume of water being moved, and therefore the speed of the ship. At 4.5 metres in diameter and weighing 14 tons each, the two propellers on the Bruges can spin at 120 revolutions a minute. They're in the process of being polished by engineer Paul Baker and his team, an essential job they can only do when the ship is in dry dock.
Once they've been polished, then we will crack detect. The areas that you crack detect are in the palm, where the bolts are, and on the tips of the blades. This is purely to identify whether or not there is any surface imperfections or fractures within the blade material.
These surface imperfections can be caused by a phenomenon known as cavitation. When the propeller's spinning, the rapid changes of pressure in the water around the blades can cause cavities or bubbles to form. The constant implosion of these bubbles as the liquid collapses into the void produces a shock wave which can damage the surface metal of the propeller. If left unchecked, cavitation could result in a ship losing a blade.
So this is being inspected at the moment?
It is. We will proceed with the polishing of the blades and the crack detection.
So when you polish it,
yes,
what's the effect that that will have?
Efficiency.
It will improve the efficiency?
It will improve the efficiency of the blade as regards the resistance within the water. So therefore, it will reduce these fuel costs. It's all about reducing fuel costs.
Those costs are further lowered by the ingenious design of the propellers, which enable the captain to control the pitch of the blades, an invention that's best demonstrated by this replica model.
Unlike in cars, where the engine speed determines how fast the car's going, that's not necessarily the case in ships. It's the angle of the blades in the water which is going to determine how fast you're moving. So when the propellers are in this position now, which they're quite flat, it's pretty much like having a dinner plate slapped onto the end of the shaft. So when it's spinning, it's not giving you any forward thrust. Now, when you start to change the pitch, you start to get an increased amount of thrust and propulsion forwards on the ship. If the captain then wants to reverse the ship, what happens is he reverses the angle of these blades completely, such that the water's being propelled in the opposite direction and the ship goes backwards. And that means he doesn't have to slow down the propeller from the forward direction, crank it in, and then speed it back up again. That whole process can be done whilst the shaft's still turning. So this clever design makes the ship that much more manoeuvrable, with quicker response times, and is more fuel efficient, making it much cheaper to run.
It's now only 10 days before the Pride of Bruges is due to ferry passengers and cargo across the North Sea. And with time running out, engineers must make sure that all the critical components, usually underwater, are in perfect working order. Any failures at sea would mean returning the ship to dry dock, resulting in a huge financial cost and a cancelled service.
A faulty rudder would prevent the crew from being able to steer the ferry into port unaided. So Paul and his team must now check that the rudder's washers and bearings, known as bushers, haven't worn down due to continual movement in the water.
You do get a wear factor on these, and sometimes you have to part the blade and the flap and renew these riding washers.
And what would be the situation where you'd have to actually remove the whole rudder?
If we have a problem with the main trunk housing, if the clearance is excessive, then we have to lower the rudder, remove the rudder, take the post out and renew the bush.
So what's the danger of not spotting something like that where you've got really high clearance?
If you've got a high clearance, you could actually lose your rudder.
At sea?
Yeah, you'd lose the rudder.
So these checks,
they're very important. They're very important.
Housed directly above the 4-ton rudders are the hydraulic actuators that move them. They're controlled electronically by the ship's steering wheel at the bow of the vessel. I'm fascinated to know how you control a ship like this. So I want to find the nerve centre. I want to find the bridge. I've arranged to meet the most important man on the ship. It's Captain Harry Cannyworth. Found the bridge.
Harry! Good morning.
Hey.
Good morning, Tom. Welcome.
This is the bridge. I've found it.
This is the bridge, yes.
It's hard to find.
It's hidden behind closed doors.
It seems to be.
For obvious reasons.
The main controls to manoeuvre the ferry in close quarters are located on the bridge's wings that protrude beyond each side of the hull so that the captain can see along either side of the vessel.
We have the bow thrusters here at our disposal.
Now, these are just those little propellers, well, say little, they're about 6 foot, aren't they?
Relatively little, and they can move the bow basically sideways. Yeah.
So, you've got rudder here?
Rudder, bow thrusters, and both engines.
I thought you'd have a wheel. I thought there'd be a wooden wheel.
You want to see the wheel? I think you'll be a little bit disappointed with our wheel. This is it.
This has been modernised, hasn't it?
This is it.
It isn't what I expected.
While the big steering wheels are getting smaller, the ships and the rudders that drive them are getting bigger.
As a passenger and cargo ferry, the ship is regularly in and out of port, so manoeuvrability is key. Therefore, the vessel has been equipped with special rudders.
These are Becker rudders. They're a high manoeuvrability rudder. You have a flap, as you can see on the mechanism here, Becker flap.
So what's the advantage of having this on the back of the rudder itself?
It actually increases the manoeuvrability of the vessel.
Water that's been driven through the propeller is diverted by the angle of the rudder, changing the direction of the ship. The addition of the Becker flap to the rudder is an ingenious yet simple way of getting extra manoeuvrability. Because of its position, this smaller flap has a bigger effect on diverting the water flow, making tighter, quicker turns possible.
So what would be happening if you're doing 18 knots, top speed?
Top speed.
Clear day?
Yeah.
And you just went woof.
The ship will list considerably.
Okay.
Everything that's not secure will fall down.
Clearly, there's no way to see Harry manoeuvre the ship while it's in dry dock. But fortunately, the Pride of Bruges has a sister ship, the Pride of York. Built in Scotland to exactly the same specifications as its Japanese sister, the York also carries out the daily Hull to Zeebrugge crossing. Between the two ships, they ferry 400,000 holidaymakers and business travellers between Britain and the continent every year.
On behalf of Pride of Bruges, would like to welcome you on board the Pride of York. The ship is now secured for sea and we will leave the berth shortly.
As dusk falls, we're offered a rare opportunity to view the most challenging parts of its journey from the bridge.
So, Alistair, why is it such mellow lighting in here?
All craft are illuminated and we have navigation lights. It's an imperative that we see those lights as soon as possible. Any background light on the bridge would spoil our night vision and we wouldn't see those other ships.
It's the same reason as in your car. You
exactly the same. Exactly the same as that. If you have bright lights in your car, you can't see what's outside the windows.
Captain Alistair McFadden shares the skipper role with his Dutch counterpart, which means tonight he's free to explain how the crew manoeuvres the ferry through a narrow lock on its departure from Hull.
But all the navigation's going on down the other end of the bridge.
It is, yeah. Captain Rowley and the chief officer, they're manoeuvring the vessel at the moment.
So this is quite an intricate manoeuvre.
It is.
We're trying to get this enormous ferry
into
this tiny little lock
pretty small gap, yes. Yeah.
So when we're in there, how much leeway have we got?
You've got about 18 inches either side of the vessel as we move in. It's a very tricky manoeuvre. We use our own machinery, main engines and bow thrusters, and of course the rudders, to get the ship in here. And as you can see, we do things very slowly and nice and gently.
That is unbelievable. From up here, I can't believe that's 18 inches. It looks like it's about an inch.
The smallest of errors could result in damage to the hull, where many of the ship's most important components are housed. But the York has been designed to the exact specifications of this particular lock.
Is it not an argument economically to have a smaller ship or a bigger lock that you can be quicker, so you can get more ships through?
The bare fact is that the lock is built, and if they'd built it twice as big, we would have built a ship twice as big.
Yeah. Now, the ship has to wait until the level of the water inside the lock reaches the same level as the river outside.
The whole idea of this dock basin is to maintain a certain depth of water all the time. So any ships inside always have a guaranteed amount of water under their keel, so they can work cargo throughout their stay in the port.
There we go.
There we go, opening up.
The crew now have to navigate the ferry 200 miles across busy shipping lanes in the North Sea.
This is the route that we'll be taking, so we'll be on the starboard side of the channel. We'll come all the way down to the sea reach. Once we get to that point, we'll alter course to a course of 124 degrees, all the way down to Zeebrugge.
Today, ships are equipped with global positioning systems that use satellites to fix the ship's location to within meters, and an automatic identification system that then broadcasts the information to nearby vessels. Superimposing that information onto the English Channel reveals how ships have to stick to lanes, like traffic on a motorway. But despite all the latest technology, a captain must still be able to fall back on the charts.
Like any prudent mariner, you don't rely on electronics. So we could take a bearing and distance from a point of land using the parallel rules here.
Yeah, recognise those.
Yeah, very simple tool, very effective. And it's used by lining up on the compass rules here, and then you line up to whichever bearing required, and then you can just simply move them across the chart to transfer a position line.
Okay.
Very simple, very practical, and sadly, soon to disappear.
Soon to disappear? How come?
Well, ships and modern ships are now moving towards electronic chart displays, and that will be their main navigational source. So all
paper,
of these paper
pencil...
charts will disappear.
Alistair's worked on ferries like the Pride of York for 38 years, and I'm keen to know if he has an emotional bond with these ships.
I think you do always develop a bond with the vessels you work on for any length of time. It's not the ship is just a vessel. It's the people on it that really make a ship. And you can have the best ship in the world with a rubbish crew, and every day drags, it's horrendous. And you can have a really older ship with lots of challenges, but with the right crew, it's a pleasure to come to work. Fantastic.
What's the most challenging thing for you when you're captaining a ship?
Weather.
The weather?
Weather.
Is that something you relish as a challenge?
I don't think I would ever say I relish the challenge of the weather, because we are mere mortals, and I think, you know, from my experience, the people that get caught out are the guys that relish the challenge.
Right.
The ferry has all the latest navigation technology to help, while sensors located throughout the vessel give early warning signs of any engineering problems and hazards, including flooding. But it still needs the skills of its crew to sail this ship safely in all weathers across 200 miles of North Sea, with up to 1,000 people on board.
This is such a gorgeous way to end a journey.
It's an incredibly civilised way to get across to the continent, isn't it?
Yeah, it really is. Very civilised.
Our arrival in the Belgian port of Zeebrugge gives us a chance to return to the ship salvage yard nearby to see what happens to a ship's carcass once it's been torn apart.
This is what ends up happening to ships at this scrapyard. Without any respect for the work they've done. They're just getting munched up by this shearer and thrown up on the scrap heap.
And this is what the salvage team are after. Steel. Mountains and mountains of steel. 750,000 tons of steel is salvaged at this recycling yard every year, ready to be shipped up the river to the ArcelorMittal steel plant, where the next stage in its life cycle begins. Here, containers the size of 3-storey buildings carry molten metal through the giant production line.
It's just so impressive, the size of the equipment and the temperatures involved.
5 million tonnes of steel is produced here every year, a quarter of which is made from scrap.
Here we have just 3 days worth, and it's all waiting to be recycled and turned into cars, bridges and fridges.
The scrap steel is loaded into enormous containers the size of a bus and transported to the converter, a vessel capable of producing 295 tonnes of steel at a time.
Oh. I mean, that is a hellish noise to match. Kind of hellish vision in a way, isn't it?
Hot metal, produced by melting iron ore in a blast furnace, is then poured on top of the scrap metal. The temperature inside the converter is now a scorching 1,650 degrees Celsius.
Wow. So as they pour the hot metal in now, it's just an incredible firework display. 220 tonnes of molten iron being poured over 80 tonnes of scrap steel. I mean, they should sell tickets for this. Unbelievable.
Steel is essentially iron, with many of its impurities removed. Specifically the carbon, which is weak and brittle. To reduce the carbon, the next stage is to add pure oxygen into the mix.
Wow. That extremely bright flame there suggests that's the oxygen lamps being put inside. They inject oxygen for about 15 minutes, which helps take the carbon that's in the metal and turn it into carbon monoxide and carbon dioxide. Once that's extracted, you're left with a more pure steel that we're looking for.
Once the converter has been emptied, the purified steel must go through a number of processes to cool it and mould it into usable sheets.
This is where they cool the ingots of steel down using water, presumably from the local river or canal. In Sheffield, they use the local rivers, and that causes the temperature in the river to rise by just enough to allow fig trees to grow on the riverbanks of South Yorkshire. Wow, that is so impressive. And this is a finished item, a huge roll of steel. What I must describe to you is how hot that thing is. You can feel it from here, it's searingly hot. Some of that once made up the ship that we saw floating on the ocean. Now it's been turned into this. Its next thing is going to be turned into your next car or washing machine.
It could even be used to build a ship.
In Newcastle, there are now just 2 days until the Pride of Bruges is due to head back into service.
Work's begun to cover the part of the ship's hull usually underwater, in a special paint designed to prevent the build-up of marine life, therefore improving the ship's fuel efficiency, as Paint Quality Inspector Tim Emerson explains.
Once that growth attaches itself to the ship, it slows the ship down. It has a dragging effect on it, yeah? Which obviously means that they've got to use more energy to drive the propellers to make the ship travel at the same speed, which obviously is impacting on the fuel costs.
I find it hard to believe that a few barnacles is going to cause a problem of fuel efficiency.
Yeah, it can cause a huge problem. The amount of fuel used to drive these vessels is huge. Typically, you're looking at around 90 tonnes of fuel a day, typically, if there was no anti-fouling on there. Once you put the anti-fouling on, you can reduce that down to between 40, 50 tonnes a day. If it was going in your pocket every day.
I'd like that up.
Yeah, me too. I would like it as well, yeah? You know, we wouldn't have to work again.
The anti-fouling paint is a technological marvel in its own right. It's been cleverly designed to react to movement of the ship through the water by continually shedding microscopic particles of itself. This means that marine life is unable to get a grip on the hull.
Every last square metre of the ship, above and below the waterline, has to be repainted. And with the Bruges already scheduled to carry passengers on the same day the overhaul is due to finish, for the next 48 hours, they have to work around the clock to get the work done.
It's the final day of the overhaul, and the Pride of Bruges is almost ready to bid farewell to Newcastle.
It's been well maintained, and I think it's a dedication of the ship staff and all departments that keep it in the condition it's in now.
Over 4 tons of paint now cover and protect the ship's exterior.
After 25 years, it's still in a very good nick, so this is a major achievement. And we'd like to keep her like this and try to maintain her as such.
The passenger levels have been refurbished.
Yeah, I'm proud that we have accomplished what we did. It looks a lot better now.
Yeah, everything what should be working is working, which is very nice to know.
Propellers have been polished and tested, and the rudders have been serviced, ready for inspection.
It's looking good, isn't it? It's looking spick and span.
It looks very good, yeah.
Now the team have to get the ship back in the water. Engineers open the sluice gates to flood the dock. Refloating the ship is a risky operation, especially in the critical moments when the ship lifts off the blocks, as docking master Alan Webster explains.
It's a term that we call the point of criticality.
Right.
That's where the ship's at its most dangerous, from being on the blocks to becoming free floating.
How do you account for the fact that there's no passengers on it, there's no cargo on it, so it's a dangerously light point?
Yeah, that's why we have to reballast before she lifts off the blocks.
Because if
we didn't, chances are the ship would capsize.
Really?
Yeah.
Okay, so to prevent that?
You've got to put the ballast back in.
Put the ballast back.
Yeah.
Late in the evening, the Pride of Bruges slowly lifts off its blocks and floats for the first time in 3 weeks. Once the level of the water inside the dock is at the same level as outside, Alan gives the signal to drop the gate.
Yeah, just checking that the gate's on the bottom, can the trucks go in?
What draft is he, Russell?
His team have a narrow window of just over an hour to manoeuvre the ship into the river before the tide goes down and it's left grounded. Tugboats slowly tow the ferry from the dock, and Alan's work is done.
Not so bad, no, it's all right, yeah. Timed it nicely.
Thanks to the work of the Newcastle engineering team, the Pride of Bruges should now be in service for another 10 years.